Welcome, my dear students. This is question number 21 of the competency series for ICSE Class 10 students. This is a very good competency level question from non-uniform meter rule. So just read the question, see how beautiful it is, and see if you are able to solve it or not. Pause the video and try it on your own, and then resume the video and see the solution. Make sure that you also watch the other questions. We have done 20 other questions before this. This is question number 21. The link of the previous questions is given in the description box of this video. So after watching this video, you can check the link given in the description box of this video. So let's continue with this question. A non-uniform meter rule. So it is talking about a non-uniform meter rule, not a uniform meter rule, of mass m. So if it would have been a uniform meter rule, the mass of the meter rule would have lied at the midpoint at 50 centimeter mark. But since it is a non-uniform meter rule, so the mass m does not lie necessarily at 50 centimeter mark. Okay, let us draw this, then it would be easy for us to understand. So this is the non-uniform meter rule. Since it is a meter rule, so its length is 100 centimeter, so we write 0 centimeter here, 100 centimeter on this side, and it is balanced horizontally. It means that it is in perfect equilibrium on a knife edge placed at 40 centimeter mark. So exactly in the middle lies the 50 centimeter mark, and to the left of 50 lies the 40 centimeter mark. So the knife edge is at 40 centimeter mark. Okay. Now what is telling further? What is the question telling further? When a weight of 20 GF is suspended from 10 centimeter mark. So the 20 GF is suspended at 10 centimeter mark. So somewhere here is the 10 centimeter and the 20 GF is suspended here. We are just drawing, we are making the diagram exactly what is said in the sentence. We are not doing anything extra. Now the rule is in balanced state. It is telling in the question that it is balanced horizontally. That means this anti-clockwise moment about the pivot is balanced by a clockwise force, clockwise moment. So which force is producing the clockwise moment? It is definitely the weight due to this mass m of the meter rule. So it must lie on the right side of the pivot. So we don't know which point it is, so let us take it as x. And here we show the mass m of the pivot. So m GF is that force, the weight of the non-uniform meter rule, which is causing the clockwise moment, which is counterbalanced by this anti-clockwise moment caused by this 20 GF weight. And now we can use principle of moments because this rule is balancing horizontally. So according to principle of moments, anti-clockwise moments is equal to clockwise moments. Anti-clockwise moments is due to this 20 GF force, which is acting at which distance from the pivot? So 40 minus 10, that is 30 centimeters, is equal to clockwise moment is due to this m force, which is acting at a distance x minus 40. We solve it further. 3 2s are 600 is equal to mx minus 40m. And if we make mx the subject of this equation, so mx is equal to 600 plus 40m. Let this be equation number 1. Simple. Now, if we read the question further, it says, if the knife edge is shifted to 30 centimeter mark. Now this is talking about a different case, case 2. So the figure which is already drawn on the screen is for case 1. This is all about case 1. Now case 2. So in case 2, what is happening? The knife edge is shifted to 30 centimeter. So we redraw the meter rule, non-uniform meter rule once again. Everything once again 0 centimeter here, 100 centimeter here. Exactly in the middle is the 50 centimeter. At mark X lies the mass of the meter rule. That means the weight is mgf here. But now the pivot or the knife edge is shifted to 30 centimeter mark, you see. So here is 30 centimeter. Let's take 30 somewhere here, and the pivot is here. Okay, the rule can be brought back to horizontal equilibrium, means again this rule can be brought to equilibrium by moving the 20 GF weight to the 0 centimeter mark. So at 0 centimeter we will show this 20 GF weight and adding an additional 10 GF weight at 20 centimeter mark. So let's show the 20 centimeter mark here, and what weight is suspended here? 10 GF. 10 GF. Now this is the picture, this is the diagram. So again, in this scenario also the rule is horizontally balanced. It is written that this rule is in horizontal equilibrium. So again we apply according to principle of moments. Again we apply the principle of moments once again here, which says anti-clockwise moments is equal to clockwise moments, which says, let's calculate. Anti-clockwise moment is due to this 20 GF. So 20 multiplied with this distance from pivot, what is the distance? 30, plus this 10 GF, which is at a distance of 30 minus 20, which is 10, is equal to clockwise moment is because of this mgf, which is at a distance x minus 30. So now the 600 plus 100 is equal to mx minus 30m. Now in this, in the place of mx, we substitute 600 plus 40m, because from equation 1 we can see that mx is 600 plus 40m. So in place of mx, from equation 1 we substitute that value. Okay, are you getting the point? It's easy. Okay, so what do? We write everything same. Now instead of mx we are writing 600 plus 40m, and then minus 30m is already there. This 600 gone, so 100 is equal to 40 minus 30 m, that is 10m. So m is 10. That m is what? The mass of the meter rule, and in terms of weight we can call it mgf. So weight is 10 gf. So that is the first part we have solved. The weight of the rule is 10 gf. So we have found out what is the weight of the meter rule. Now they are asking us calculate the position of center of gravity. So this mass m, which is the weight due to this mass m, is present at mark x. That means the center of gravity is here. We know that the weight always acts at center of gravity. The weight of the meter rule will always act at the center of gravity. So this x is that point where the center of gravity is acting. So we need to find what's the value of x. So we use this equation 1 once again easily. So using equation 1, which says mx is equal to 600 plus 40m. So m we have already calculated, which is 10. So 10x is equal to 600 plus 40 into 10. M value we have already calculated, right? So this is 600 plus 400, that is 1000. So x is 1000 divided by 10. That means x is 10 centimeters. So very clear that therefore the center of gravity lies at 10 centimeter mark. So this is how you solve this question. Isn't it so simple? So I hope you liked this question, you enjoyed this question. Make sure to subscribe to the channel and press the bell icon so that you do not miss out any of the videos which I am putting in this series. See you all. Take care. God bless you.